Hi! In the last video, we talked about plane mirrors, and those are mirrors that are flat. Well, in this video, we're going to talk about curved mirrors. So yes, you will need a protractor to help you with some of the drawings. So there are many different types of curved mirrors, but the ones that we're going to focus on are spherical or mirrors that are circular in shape. Okay? And so we're going to have circular or spherical mirrors. All right, so I'm going to draw a circle, I guess, mirror, but before I do that, I'm going to draw a dot, and that will represent the center of my circle. I'm going to line it up with the center of my protractor like so, and now I'm going to draw the actual outside or trace the outside of the protractor. So now the protractor gives you a nice circle, and so there is my nice circular mirror. All right, so this here is the radius, but in physics or optics, we call this the center of curvature, not the radius. So the center of curvature. Okay, and I'll write radius. Okay, and this here is the backing of the mirror. Now we can also make the backing on the other side and this side shiny, and that's a different type of mirror. It's called diverging mirror. This example is called a converging mirror. We will show you the other example in a minute. So this is called a converging mirror. Perfect. All right, converging mirror. This here is your center of curvature. And the last thing I need to mark down is the focus. So what is the focus? That is the distance between the mirror itself and then the radius or the center of curvature. And we're going to take that distance and divide it by 2. So it's halfway. So 5 centimeters, as you can see, and that's going to be halfway, which is 2.5 centimeters. And this here is the focus. Focus. And that is pretty much halfway between the center of curvature and the mirror. Perfect. Okay. Another thing I need to draw is actually something called the principal axis. The principal axis is where you line up the focus and the center, like so, and typically I would draw a dotted line. Now, a lot of these diagrams in your textbooks or online, they don't draw the principal axis, and you don't need to draw the principal axis as well, but this is good because you'll need to in the future for lenses. All right, so this here is called the principal axis. Okay, so now let's have a light ray. Let's suppose there's some light from a far, far away place, and it's coming in, and it happens to be parallel to the principal axis. This is why I insisted on making sure it was this principal axis was there, because I want it parallel and I want everyone's diagrams to be similar. So let's do a light ray coming in that's parallel to the principal axis. So here's your light ray. Remember, don't forget the arrows so you know the light's coming this way. And I'll just sort of draw a light or a sun to represent the light coming in, and this is called the incident ray. Perfect. Now, remember, light does obey the rule of law of reflection, which is the angle of incidence equals to the angle of reflection. So I'm going to tell you that it does obey that, and when it obeys that, the light will be reflected and it will actually be focused or sent through the focus. So it will be sent through this way. Okay? So this here is your reflected ray. Now, how am I so sure? Well, let's double check to see if that angle or the angle of incidence equals to the angle of reflection. So I'm going to rotate this so it's easier for you to see or visualize. Remember, we have to draw the normal. The normal is 90 degrees from the surface to that normal, that dotted line. Remember, you're drawing the radius here. By default, the radius, if you draw a line from the radius to the outside, it will automatically be 90 degrees. So this here is your normal. Okay. Let's make sure it's drawn correctly. Perfect. That's my normal. Okay. And I'll write it here. Normal. Okay. And you can pretty much tell by eye that this angle here looks pretty much equal to that one. This one here is theta I, the angle of incidence, and this one here is theta r, which is the angle of reflection. And so hopefully your diagram turned out to be equal. They are equal. And if you're not sure, just measure it. And hey, look at that. That's not bad. That's pretty equal. If you measure it, here you go. This is from the normal, 10, 20 and a little bit. So this is like 22, 23 degrees. And let's try the other way. 10, 20, and oh, look, 22 degrees. So judging by this, and remember, it's just a diagram. It's slightly inaccurate, all right? Because, you know, of the thickness of the marker and your drawing technique, you're not going to be perfect. This here is about 23 degrees, and that's about 22, 23 degrees. So that definitely obeys the law of reflection, okay? So here, the law of reflection is followed, okay? You have to make sure it works. So yay, that's good. So basically, what am I saying? I'm saying that all parallel rays coming in, so parallel rays, parallel principal to the axis, is all going to go have their reflected rays through the focus. Let me draw that so you can actually see what's going on. And this is why this is called a converging mirror, because you're going to converge the light at the focus. So let's draw another diagram, and I'm going to show you what I mean, okay? So let's grab our lovely protractor here. Okay, perfect. I'm going to draw my dot, which is the center of the protractor. I'm going to draw the outside of my protractor. Perfect. Then I'm going to, so this is your center of curvature. Now I'm going to draw the focus. So at 2.5 centimeters, because that's halfway. So this is my center of curvature. This is my focus. And this here is the back of my mirror. Okay, and this is called a converging mirror. Okay, and oh, let's not forget to draw our principal axis. So here is our principal axis, and we'll call that the PA for short, PA. And let's draw a light ray that's parallel to the principal axis. So we already drew one down here. I'll draw it again. Okay. We can draw another one up here, like so. We can draw a third one over here. Okay. Third one over here. And oh, let's draw a fourth one over here just for fun. Okay. So this here is a light coming in. Each light beam is going to reflect off the mirror, and it's going to line or go through the focus. So here's the first one, right? Here's the second ray. It's going to go through. And if you want to double check to see if the angle of incidence equals the angle of reflection, yes, you can for each one if you like. All right, you can measure it out. So let's do that. And the last one over here will go like that. So these are all the reflected rays. Perfect. Okay, so this is called a converging mirror because the light converges at the focus. The light converges at the focus. So basically, where can we use this really cool, I guess, law or rule for curved mirrors? Well, we use it actually in flashlights. All right, so here are examples of where this is used. If you look at a flashlight, what they did is they put a light bulb here, and then the light goes away from the focus and then into a parallel beam. So in other words, what I'm trying to say is that you can actually reverse it. You can put the source of light here, okay, and then the light travels out, reflects, and it's still equal angles. Law of incidence equals law of reflection. Or sorry, not law, so angle of incidence equals angle of reflection, and the light will come out this way. All right, and so an example of this use would be something called like a flashlight, and you'll notice all flashlights are shiny with the bulb at the focus. Another example of this would be your car headlights. So your car headlights. That's also a really cool example. The light bulbs here, the shiny surface there. Now for car headlights, it's typically not spherical, but more like elliptical. So it's more squished to get a higher concentrated beam of light to, light up the road. So those are kind of the examples. Another example too is satellite dishes. All right, so satellite dishes. You'll notice satellite dishes are all spherical like this, and what they do is they point their dish in the sky, okay, or to the sky, and they collect the radio waves or the light waves, and typically there's a little nubby. All right, what they do is they have a little nubby like this, and then you have the little nubby over here in the satellite dish. Okay, so that's for the satellite dish to collect the information. And so this is a very handy way of collecting information from far, far away, such as a satellite dish. All right, let's do the other type of curved mirror. This is when the inside is shiny and not shiny, the inside is the backing and the outside is shiny. And we call that a diverging mirror. So let's draw another curved mirror. All right, so I'm going to draw my curved mirror. I have, I'll draw this nice little dot over here. All right, on this side, for example, and draw a nice curve like so. And I'm going to draw the focus. Again, it's halfway. So let's do the focus, which is halfway, which is right here. Okay. And the difference is the backing is on the inside. And if you can't remember what the backing looked like before, this is the converging mirror. This is the reverse. So this is called a diverging mirror. All right. Let's also label the principal axis as well. We'll just make sure that these two are lined up. Okay, perfect. And we'll draw out the principal axis as well right here. Perfect. So this is center, the focal, and this is your principal axis. All right, let's try this. We're going to have a light coming in from the outside in this case, or the other side, and the light's going to be parallel to the PA. And in this case, because the focus is in the mirror, it's actually going to reflect the light. It's going to bounce off of it before it can get there. But when it bounces off, it's going to bounce off as if it came from the focus. So I'm going to line up the focus and the point of intersection here, and it's going to bounce off. All right, and that's the point where the light has been reflected. So here's your incident ray coming in and reflected. Okay, notice that the law of reflection still applies, right? If I line up the center of a curvature with the point of reflection, which is right here, that intersection, this here's your normal. Okay, normal. Hey, take a look at that. That looks like pretty equal angles right there. See this angle here, angle of incidence, angle of reflection. Okay, in this case, again, angle of incidence equals angle of reflection, and that works too, which is very cool. So that means anytime a parallel light, and let's just draw a whole bunch of parallel lights, for example. So here we have another parallel light. Let's draw another one up here. And hey, let's do one more. Let's do one between, sure. Okay, so here we have a bunch of light coming in parallel, like so. They are all going to reflect as if they're reflecting off the or from the focus. Let me just complete my line. I got to make sure it hits the mirror. So make sure it hits the mirror. And then now it hits the mirror at this intersection. And so there you go. That's going to go off that way. This one is going to go off this way. Okay. And this guy will probably go off, oh, that way too. Let's go off that way. Let's draw one more so you can see how it goes off the other way as well. So let's just draw one on below the principal axis. Okay, and you'll notice that if you line it up, it does bounce off that way, away. So as you can see, it looks like it came from the focus. And if you actually draw the dotted line back, it does look like that, doesn't it? So I'll just draw dotted lines back, as you can see. So I'm lining up your reflected ray back to the focus, like so. And let's do this one. Yeah, let's do that one. Here we go. Perfect. All right, so it looks like it's coming away, and that's why it's called a diverging mirror. It's like going away from the focus. So this is going away from the focus. Perfect. All right, so there you have it. You have a converging mirror like this, where light converges at the focus, so it's obviously the focus, you're focusing there, and a diverging mirror, and that's the opposite, where the light is coming away or going away or scattering from the focus. All right, we're going to do a lot more ray diagrams in the next video. See you then. Bye.